finds dividing dendrites like this, this is typically a Purkinje cell of cerebellum, because only in Purkinje cell of cerebellum you will see this diffuse dendritic pattern of distribution of the dendrites. This is the biggest cell in the cerebellum. This is a histology slide. So this is a contrast imaging which is showing you a Purkinje cell. With that, we complete our discussion on Grand Test 4 physiology questions. Please subscribe to our Advanced Plus V2. We have special features of pre-recorded videos of more than 600 hours, an extensive question bank with more than 20,000 questions, and 19 subject-wise tests, image-based tests, grand tests, and mini tests with clinical videos and demonstrations. We also have hard copy of the notes with revision videos and also daily mentorship programs. Thank you so much. With this, we complete our session on Grand Test 4 discussion. Thank you. I'm just repeating the questions because of some technical issues. I'm just repeating the same questions again. Physiology, Power Grand Test 4, discussion of questions. The first question was, the rate of synthesis of various forms of hemoglobin is given in the diagram. Gamma chain is indicated by which of the following curve? So this diagram shows the chains are indicated, the polypeptide chains on y-axis, and also you can see the period of gestation on x-axis. Before, this is a point of birth, before birth and after birth. Before birth, this is called the fetal hemoglobin, and after birth it is adult hemoglobin. Fetal hemoglobin is made up of alpha chain and gamma chain. Adult hemoglobin is made up of alpha chains and beta chains. See, that is why the chain which is sustaining throughout is alpha chain before birth and also after birth. The chain that you can see during the fetal life is specifically gamma chain. The chains that you see specifically in adult life, adult hemoglobin, is beta chain. So from the graph, A is alpha chain, B is gamma chain before birth, fetal hemoglobin, and D is beta chain after birth in adult hemoglobin. During the embryological period, initial few weeks of gestation, it is epsilon chain. It's called epsilon hemoglobin. So from this diagram, gamma chain is indicated by option B. This is gamma chain because it is fetal hemoglobin. So gamma chain. Over to question number 2. A 51-year-old female presented to the emergency with blurred vision, headache, dizziness, vomiting with one-day onset. On examination, there is flaccid paralysis. Flaccid means the muscles are becoming loose like this. This is called flaccid paralysis. And the husband is also reporting the same. A history of homemade sausage, broad beans, honey consumption was registered. It means both these people, husband and wife, have eaten the same food from the same house. So it's a case of food poisoning. Poisoning which is very common in sauce bottles, honey consumption, is Clostridium botulinum poisoning. So it's a case of Clostridium botulinum poisoning. What is the mechanism of action of Clostridium botulinum? It's a blocker of SNAR protein. What is SNAR protein? Synaptotagmin, synaptobrevin, syntaxin and SNAP25 are called as SNAP proteins. What are these SNAP proteins? They help to release acetylcholine. The function of SNAP protein is to release acetylcholine at the neuromuscular junction. But Clostridium botulinum is a blocker of SNAP protein. If you block SNAP proteins, you are blocking the release of acetylcholine. If there is no acetylcholine, contraction decreases. If contraction decreases, muscles will go without contractions. See, this is normal muscle tone. If the muscles are losing contraction, they will become like this. This is called flaccid paralysis. If the muscles are becoming too contracted, it is called spastic paralysis. But here, if the muscles are becoming so weak like this is called flaccid paralysis. So, Clostridium botulinum is a blocker of SNAP protein. If you block SNAP protein, you are blocking acetylcholine. If you block acetylcholine, contraction decreases. When contraction decreases, muscles will go for flaccid paralysis. So, the answer is blocker of SNAP protein. There is another Clostridium called Clostridium tetani. This is exactly opposite of botulinum. Tetany causes spastic paralysis. What is spastic paralysis? Clostridium tetani is a blocker of GABA and glycine. GABA and glycine are inhibitory neurotransmitters. If you block the inhibitory neurotransmitter, without inhibition, acetylcholine increases. More the acetylcholine, more the contraction. This is called spastic paralysis. And that is how tetany causes sustained contraction. That is called spastic paralysis. So, botulinum causes flaccid paralysis by blocking SNAP protein, and tetany causes spastic paralysis by blocking GABA and glycine. So, the answer to this question is option C, blocker of SNAP proteins. Question number 3. Which of the following events succeeds first heart sound in cardiac cycle? What happens immediately after first heart sound? Let's learn about cardiac cycle first. This is a diagram of cardiac cycle. What is cardiac cycle? Every time your heart beats, for one heartbeat, what is the pressure change inside the heart and volume change inside the heart? That is called cardiac cycle. For every heartbeat, what is the pressure change and what is the volume change? How will you read the cardiac cycle diagram? First, read the pressure changes. The topmost curve here is aortic pressure curve. The biggest curve that you see, ventricular pressure curve. This small curve that you see, atrial pressure curve. And there is one volume curve, the ventricular volume curve. So we have pressure curves and volume curves in the cardiac cycle diagram. Now let's see what are the phases of cardiac cycle. What is cardiac cycle? For every heartbeat, the pressure and the volume change. What is a heartbeat? Contraction, relaxation. Contraction is called systole, relaxation is called diastole. So one systole and diastole is cardiac cycle. We have atrium and ventricles. So atrial systole, atrial diastole, ventricular systole and ventricular diastole. These are the phases of cardiac cycle. We'll put that into the diagram. First event, atrial systole, followed by atrial diastole. But atrial diastole is a very insignificant event. No significant changes takes place during the atrial diastole period. So it is negligible. Leave it. Followed by ventricular systole and ventricular diastole. How will we fit valvular events into this? At the end of atrial systole, atrium has contracted and pushed blood into the ventricles. Which valve will close? This is AV valve and this is aortic valve. At the end of atrial systole, atrium has pushed blood into the ventricles, so AV valve closes. So at the end of atrial systole, you can mark AV valve closure. When AV valve closes, it means ventricle is filled with blood now. Which valve will open? Aortic valve opens. So immediately followed by aortic valve opening. AV valve has closed, aortic valve has opened. But in between these two periods, when AV valve has closed, aortic valve is still not yet open. It is still closed. AV valve has closed, aortic valve is just going to open. There is a small period where both the valves are closed. When both valves are closed, there is no outlet for the ventricle. If there is no outlet for the ventricle, the volume in the ventricle remains same. So this period is called isovolumetric period. It is followed by ventricular contraction. So it is called isovolumetric contraction period. After AV valve closure and before aortic valve opening, it is called isovolumetric contraction. At the end of isovolumetric contraction, aortic valve opens. The aortic valve opens, ventricle contracts, pushes blood into the aorta. So after aortic valve opens, there is ventricular systole. Ventricle contracts and pushes blood into the aorta. Once blood has gone into the aorta, aortic valve closes. When aortic valve closes, again AV valve will open. But here also there is a small period where both the valves are closed. Aortic valve has closed, AV valve is just going to open. Small period where both valves are closed. If both the valves are closed, volume in the ventricle cannot change. So again it is called isovolumetric period, but it is followed by ventricular diastole. So it is called isovolumetric. Diastole means relaxation. So it is isovolumetric relaxation period. How will you fit heart sounds into this? Two heart sounds, S1 and S2. First heart sound, second heart sound. Heart sounds are heard when a valve closes. First heart sound is heard when AV valve closes. Second heart sound, S2, is heard when aortic valve closes. So what is the question here? This is the point where you hear first heart sound, S1. S1 is succeeded by which event? What is this green event? Isovolumetric contraction. After AV valve closes, there is isovolumetric contraction period and then only aortic valve will open. So S1 is succeeded by isovolumetric contraction. That is why the answer to this question is option A, isovolumetric contraction. Over to question number 4. A twofold decrease in extracellular potassium level causes which of the following? What is decrease in potassium? That's called hypokalemia. What is the effect of potassium? Potassium is responsible for RMP. At RMP, potassium has a tendency to move out. At resting membrane potential, potassium moves out. This movement of potassium only is responsible for RMP. But in hyperkalemia means there is more potassium outside. If you have more potassium outside, now this potassium can't move against the gradient. It can't go from low to high. It's very difficult. So if potassium increases outside, this gradient is destroyed. If this gradient is destroyed, potassium can't move out. Potassium can easily move from high to low, but from low to high it can't move. So whenever potassium is more outside, the gradient is destroyed and therefore potassium is not able to move out. So more potassium stays inside itself at RMP. If more potassium stays inside, potassium is a positive ion, it will increase the positivity. So RMP goes towards positivity. So in hyperkalemia, RMP goes more towards positivity. In the diagram, in the graph given, if point D with membrane potential on y-axis and time on x-axis, if this line is RMP, point D is RMP, neutral line, this is RMP. In C, B and A, you will find that RMP has gone towards positivity. When will RMP go towards positivity? In hyperkalemia only it will go up. So this line will be shifted up in hyperkalemia. But the question is about hypokalemia. A twofold decrease in extracellular potassium is hypokalemia. Hyperkalemia, RMP goes positive. In hypokalemia, it will go negative. So in hypokalemia, it becomes negative. From this normal RMP, it goes down. So which is the answer? Point E. In hypokalemia, it becomes negative. That is the reason why hyperkalemia increases the excitability, because if RMP goes towards positivity, easily it can be excited. And hypokalemia decreases the excitability. Hyperkalemia, cells become more excited. That is why in hyperkalemia, cardiac cells become more excited and you have arrhythmia. So hyperkalemia increased excitability, hypokalemia decreased excitability. So in this question, the answer is option E. The fifth question, identify the cell type shown in the image. This is the largest cell of cerebellum, the Purkinje cell. How will you identify? This is the cell body. The dendrites are dividing multiple times into extensive patterns. So if you see multiple dendritic divisions like this, diffuse connectivity of dendrite, typical of Purkinje cell. Only Purkinje cell will have such diffuse type of connection. It's an example for multipolar neuron. And this cell which is given here, it is a image of Purkinje cell, the largest cells in the cerebellum. So with that, we complete our discussion on Grant Test 4 Physiology questions. And please do subscribe to our Advanced Plus version with pre-recorded videos, extensive Q bank, competitive test series, clinical videos and demonstrations with hard copy of notes, and all 19 subject 160 hour of revision videos with daily mentorship programs. And thank you so much for joining in our session of physiology discussion. Let's join in for another session of physiology discussion. So any doubts you can post, otherwise we are done. Thank you.